Hello and welcome back to Diksha Karnataka YouTube channel. We are currently solving previous year question papers for KCET. If you are currently preparing for KCET 2025, don't miss out on this series. We have already covered KCET 2024 question paper in two parts. Also, we have covered KCET 2023 questions from question number 1 till question number 30. Currently, we are going to solve from question number 31 till question number 60, and the description for question number 1 to question number 30 will be given in the pinned comment below. Don't miss out on that if you have not seen that video yet. Now let's start on the journey for question number 31 till question number 60. So question number 31, for a given pair of transparent media, the critical angle for which color is maximum? We know that for critical angle theta c, the refractive index of the medium is given by sin theta c, right? So mu, that is refractive index, is given by sin theta c. Now mu is given by c by v sin theta c, right? Now v is basically frequency. Just a second, you don't write frequency with n anymore, so it is nu lambda, right? Nu is the frequency, is equal to sin theta c. So we can see that sin theta c, that is the sign of the critical angle, depends on the inverse of the wavelength. So we can say that theta c is directly proportional to 1 by lambda. So whoever has higher lambda has higher critical angle. So critical angle for higher, which one has the higher lambda? We know that V for violet, and it comes to red. V has the lowest lambda and R, red, has the highest lambda. So for red, the critical angle will be maximum. So the correct answer is option A for this question. Next question. In an equiconvex lens made of glass of refractive index 3 by 2 has a focal length f in air. It is completely immersed in water of refractive index 4 by 3. The percentage of change in the focal length is very important question. Let's solve it together. We know that from lens maker formula 1 by f is equals to mu minus 1 by r1 plus 1 by r2 for equiconvex lens. For equiconvex lens, this can be written as 2 by r, right? For equiconvex lens, this can be written as 2 by r. Now here generally there is mu air is there, but mu air is generally 1, so that's why we generally do not use air, because it is 1. But for any other medium you have to use that mu in the division. So for air, first case where, so in the air, say focal length is f air, okay? So mu is 3 by 2 minus 1 times 2 by r, right? So it will be 3 by 2, 3 minus 2 by 2, 2 by r, or you can write this as 1 by 2 times 2 by r, 2 cancels, it is 1 by r. So 1 by fa is 1 by r, or we can write fa equals to r, okay? This one is our first information that we have collected. Let us keep that. So f in air, let me write it here, f of air is equals to radius of curvature r. Any one of the surface radius of curvature r is equal to the focal length. Now when it is in the water, say focal length is f w, okay? Then from lens maker equation we can write 1 by f w equals to mu glass divided by mu water minus 1 times 2 by r, okay? Same formula, only thing is here previously it was air, so mu was 1. For water you have to use the mu of water, so it will be 3 by 2 divided by it is mentioned 4 by 3. So 4 by 3 minus 1. times 2 by r. Okay. So, let me write it, these 3 will go up. So, 3 times 3 and these 2 will multiply, 2 times 4 minus 1, 2 by r, or you can write this as 9 by 8 minus 1 times 2 by r, or you can write this as 1 by 8 times 2 by r, that is, what is the value? This is cancels. So, 1 4 is left. So, 1 by 4r, right. So, in case of water, the focal length becomes 4r, right. In air it was r, in water it is 4r. Now, tell me if the focal length increased or decreased. Focal length increased or decreased? Focal length increased, because final focal length is more. So, focal length increased by 4r minus r, that is 3r. Focal length increased by 3r. So, percentage change is Fw minus F air divided by F air equals to 3r by r, cancels, times 100%, that is 300%. So, the correct answer is 300% increases. So, it is not decrease, it is only increases. Okay. Now, let us move on to the next question. A point object in moving at a constant speed of 1 meter per second along the principal axis of a convex lens of focal length 10 centimeter. The speed of the image is also 1 meter per second when the object is at dash dash centimeter from the optical center of the lens. Now, very interesting question. You can do all the mathematics here, but this question is not mathematically, you can solve it mathematically, but this question can be solved easily without using any mathematics, only knowing that this thing is possible, that speed of object and speed of image, they are equal only when u is equals to v, right. So, u, that is object distance, is equals to v, object distance equals to v. When it happens only when the object is located at 2f from the lens, right. So, we can say that the object distance is 2f, that is 2 times 10, that is 20 centimeter. So, we know that when object is at 2f from the center, the distance is actually equal. So, the correct answer is 20 centimeter, that is option C. Okay. Now, when the light propagates through a given homogeneous medium, the velocities of primary wavefronts are lesser than those of secondary wavelets. Primary wavefront and wavelets are equal. The primary wavelengths and is greater than or equal to those of the secondary wavelets. Primary wavefront are larger than those of the secondary wavelets. So, always remember, in case of velocity, primary as well as secondary all move at the same speed of light. That is the Huygens principle. They are source of light. So, basically speed of light or velocity of light, both cases are same. So, primary and secondary both moves with the equal speed, that is primary wavefront and wavelets are equal. Wavelets means secondary wavefronts. Okay, wavelets are children's or secondary wavefronts. So, primary wavefront and secondary wavefront both are moving at the same speed. Now, this question is basically out of syllabus question. Currently quality factor is no longer in your syllabus, but let me tell you the answer. So, in this question it says total impedance of series LCR circuit is varies with the angular frequency AC source connected in shown in the graph. The quality factor Q of this LCR circuit is, so quality factor is the resonance frequency is this. Okay. Even though it is given in terms of angular frequency, the when we are calculating quality factor, it will be a ratio, so that 2 pi factor will be cancelled. So, do not need to worry about it. So, the resonance frequency is 500, divided by the bandwidth. So Z mean and root 2 Z mean, that means this is the bandwidth. Bandwidth is 600 minus 400, that is 200, that is 2.5. So the quality factor is 2.5 even though it is deleted. Now in the Young's double slit experiment, the intensity of light passing through each of the two double slit is 2 into 10 to the power of minus 2 watt per meter square. The screen slit distance is very large in comparison with slit distance. The fringe width is beta. The distance between the central maximum and the point on the screen is beta by 3, x equals to beta by 3. Then the total light intensity of that point. Now this is also partially deleted because we know that fringe width is deleted, so beta is deleted, so we are not considering beta, but still if you want I am going to solve it. We know that intensity is given by 4 I naught cos, sorry, not cos, not sine, cos square phi by 2. Okay, so this is the formula that we are going to use. This formula is there in your syllabus, but how the phi is related to fringe width beta, that is no longer there in your syllabus, but I am going to solve it. So phi is pi beta by x, sorry, phi is pi x by beta. Okay, so we can insert the values. X is beta by 3, x is beta by 3, beta beta cancel, so it will be pi by 3. Now if you put the value, I equals to 4 I naught, okay, cos square phi by 2. Phi by 2 means pi by 3 by 2, that is pi by 6, that is cos 30 degree. Cos 30 degrees value is, what is the value of cos 30 degree? Yes, that is half. Now there is a square, so you have to use the square. So you have to use I equals to 4 I naught times 1 by 4, 4 cancels, that is equals to I naught. Now what is the I naught's value? I naught's value is 2 times 10 to the power minus 2 watt per meter. So the correct answer is C, 2 meter per 2 watt per 2 into 10 to the minus 2 watt per second. Okay. Now let's move on to the next problem. A 60 watt source emits monochromatic light of wavelength 662.5 nanometer. The number of photons emitted per second is. Very interesting question, beautiful question. Let's try to solve it. We know that the energy of a photon, one single photon is given by, energy of a single photon is given by energy of a single photon is given by E, one single photon, I am writing E1, that's why H nu, right, or H C by lambda. Nu is C by lambda, right. So this is for a single photon, this is the energy. Now in this case we also know that Hc is 1242 EV. I am just assuming 1240 for now, okay, 1240 EV nanometer, okay, EV nanometer, right, divided by lambda is given 662.5 nanometer. Now we will do some approximation in this problem to get the answer, but I can guarantee that approximation will not hamper our final result. So 1240 in the bottom it is 662, so almost double. So 600's double is 1200, and even though it is not exactly double, but we can say it is almost double, say 1.9 or approximately. I am writing it 2 for now, because these calculations, these values are not going to be shown to the teacher when you are solving it. You can take these approximated values, as long as your final answer matches, does not matter, right? So you can take this 2 eV, right? So 2 eV is the energy of one single photon. Now assume that there are n number of photons emitted, n number of photons emitted, then n number of photon emitted per second. Then what is the total energy of these photons? N into 2 eV, right? Now if there is no loss of energy, this should be equals to the power supplied by the bulb, that is 60 watt. Now on the right hand side it is watt, on our left hand side it is eV. So how we can convert eV to joule, right? This is per second, so watt becomes joule, does not matter, right? Per second means watt is actually 60 watt times 1 second is joules. So 60 joules on our right hand side, on our left hand side it is eV. So we cannot compare that, so we have to convert it into joules. So it will be equals to 60. 1 eV is 1.6 into 10 to the power of minus 19 joules, right? So we have converted successfully. Now we just need to solve it to find the value of n, right? Now again we are going to do one more approximation. What is that approximation? 2 times 1.6. 2 times 1.6 is 3, right? 2.1.6 is 3. It's not 3, it's 3.2, but we are approximating it to be 3 because we also approximated it, it was lower than 2, but we have increased in that case. In this case what we are doing, we are decreasing it, so that it gets balanced. You can check the answer using your calculator and tell me if there is any discrepancy in this case. So this is the value. So n will be equals to 60 divided by 3 times 10 to the power minus 19 goes to the other side, becomes plus, right? So 20 times 10 to the power of 19, or 2 times 10 to the power of 20. So let's see what answer is given. So the correct answer is 2 times 10 to the power of 20. If you have any doubt, any question, don't forget to mention that in the comment below, so that we can discuss that in our future videos. In an experiment to study photoelectric effect, the observed variation of stopping potential with frequency of incident radiation is as shown in the figure. The slope y and y-intercept are respectively. So here they have given you a graph. So y-intercept is this. So if you are wondering what is y-intercept is this, and the slope, that is means whatever the angle is given, tan theta of that is the angle. So if you can find the equation of this line, then you can then you will be able to answer this question. Now remember that this is not energy versus frequency, this is stopping potential versus frequency. So we know that photoelectric emission equation, that if the frequency is nu, then h nu is equals to charge of an electron emitted by electron. So E V naught is the potential. Okay, that is the basically this is represents the total energy of a emitted electron, minus h nu 0. So nu 0 is the starting frequency, right? Threshold frequency. Now from this equation, if you rearrange it, what you will get? Sorry, this is EV0 plus h nu 0. So basically this much energy is required to jump the energy band gap, and this much energy is gained by the electron to move across. So EV naught is equals to h nu minus h nu naught. I will explain why I am writing it like this. So V naught is equals to h by E into nu minus h nu naught by E. Now if you see what is along y axis, we have stopping potential V naught. So we can write this as y is equals to, and what is along x axis? Along x axis the frequency of radiation, that is nu. So we can write this as y equals to mx plus c. That is our familiar straight line equation. So if I give you this equation, then you will able to say what is the slope. Slope is m. Now compare this. This is y, this is x, right? So m must be this. So from this we can write slope must be h by E. right? And this is the intersection. Intersection is basically this C. So what is the intersection? You have to take the sign as well. So intersection C is minus H naught by E. So from the given option, if you see which one is correct, this one is correct. So H by E minus H naught by E. So you have to just rearrange the equation so that you can write the answer. Okay, nothing much, no rocket science, very simple. Next, in the Rutherford's alpha scattering experiment, as the impact parameter increases, the scattering angle of the alpha particle is always 90 degree, it increases, it decreases. So you should know that the relationship between the impact parameter and the angle is basically it is decrease. As the impact parameter increases, the scattering angle decreases. So scattering angle will decrease. Of hydrogen atom and corresponding wavelength of the emitted radiation due to different electron transmissions are shown in the figure, right? So hydrogen energy transmission due to different emission is shown in the figure. So from E3 to E2 is lambda 3, from E2 to E1 is lambda 1, and from E3 to E1 is lambda 2. Okay, so this is the three emission lines are shown. Then they have asked you to find the relation, which relation is correct. So we know that whatever is this energy difference, okay, that should be equals to the energy gap, right? That is H nu, right? So we can write that E3 minus let us start with the first one. So first one is lambda 1. So E, it is jumping from E2. So E2 minus E1 is equals to H nu 1, right, or Hc by lambda 1, right? This is the first relation. Similarly, we can write E3 minus E1 is equals to Hc by lambda 2, right? Lambda 2 is from E3 to E1. Similarly, E2 minus E1 is equals to Hc by lambda 3, right? These are the three equations that we are going to use to solve this problem. How we can use these two equations to solve this problem? So first, what we will do, this is just a second, this is E3 minus E2. Okay, lambda 3 is from E3 to E2, so E3 minus E2 is Hc by lambda 3. Now what we will do, we will try to simplify this. First, from these two equations, we will try to eliminate E1. How we can eliminate E1? So we will do, suppose this is equation 1, this is equation 2, this is equation 3, then let me write equation 2 minus equation 1. Then what we will get? We will get E3 minus E2. E1 will cancel. So this was minus E1. The last half this will become plus E1. So they will cancel. So E3 minus E2 is equals to Hc by lambda 2 minus Hc by lambda 1, right? So we are doing minus, right? Now what is E3 minus E2? E3 minus E2 is Hc by lambda 3. So Hc by lambda 3 is equals to, let me rewrite this, okay? Let me rewrite this. Hc by lambda 3 is equals to Hc by lambda 2 minus Hc by lambda 1, right? So we did 2 minus 1. Now what they have asked you? They have asked you to find different values, and each cases, see, each cases there is no negative value, each cases there is only positive, okay? Everything is positive, right? So what we have to do, we have to find a combination where everything is positive. So what we can do, we can take this negative terms on this side so that this becomes positive. So this is only alone is left there. So let me write the alone value first. Hc by lambda 2 equals to Hc by, this one comes on this side, so lambda 1 plus Hc by lambda 3. Now Hc all cancels, so these Hc's are cancels, so only one is left. Here also this is cancels, so only one is left. Here also this is cancels, and only one is left. Right? Now from the parallel resistance combination, we can simplify this simply by using one line only, that lambda 2 is basically lambda 1 lambda 3 by lambda 1 plus lambda 3. Okay. Remember, when two resistors are in parallel, we can write R1 R2 by R1 plus R2. Similarly, we can write this using the same logic. We can calculate this as like this. Okay. So lambda 2 becomes lambda 1 lambda 3 divided by lambda 1 plus lambda 3. Right. So what is the correct answer? Then this is the correct answer. So you have to be careful what you are achieving, how you are achieving. This is the hint that plus, everything is plus, that means there would be no negative, so you have to make everything plus, right? Now let's move on to the next part. An unpolarized light of intensity I is passed through two Polaroids kept on one after another with their planes parallel to each other. The intensity of light emerging from the second Polaroid is I by 4. The angle between the pass axis of the Polaroid is. So very interesting question. So what we are given that there are two Polaroids, okay, and their pass axis makes some angle, say theta, okay. Unpolarized light of I is passing through this. After passing through the first Polaroid, we know that the intensity becomes half. If you have not seen our 2024 video, the similar question came in 2024 as well. Okay, that was little bit complicated because there are two more Polaroids are there, but this is simpler. So first unpolarized light becomes half the intensity when it is passing through the first Polaroid. Okay, this is the polarizer. Now after that polarizer, okay, when it is passing through the second polarizer, what happens? Then Malus law kicks in. So Malus law says it will be I by 2 cos square theta. Whatever is this angle theta, that is cos square theta. Now this is given, this I is given. Okay, this is the I dash. So I dash is given as I by 4. Okay, so this is equals to I by 2 cos square theta. I cancels. Okay, so we get cos square theta equals to 1 by 2. This cancels, so only 1 by 2 is left. So cos theta is equals to 1 by root 2. Now when is cos theta 1 by root 2? Cos 45. So theta is equals to 45. Right? Simple. Now let's move on to the next question. A nucleus with mass number 220 initially at rest emits an alpha particle. If the Q value of the reaction is 5.5 MeV, they calculate the value of the kinetic energy of the alpha particle. This part is no longer in your syllabus, but the answer will be 5.4 MeV. You can check that out, but Q value and alpha emission both are not part of your syllabus. Okay. A radioactive sample has half-life of 3 years. The time required for the activity of the sample to reduce 1/5 of the initial value is. This is also again out of syllabus question. This is a very long question, very lengthy answer. The correct answer will be 7 years. You can check that out later on if you want. If you are preparing for JEE Mains or any other exam where this is still in the syllabus, you can mention that in the comment. I will solve it for you. Now, when a PN junction diode is forward biased, which type of charge carriers flow in the connecting wire? Ions, holes, protons, free electrons. Okay. Now this is very interesting. I know 90% of you are still will be able to answer, but 10% of you may be thinking what is the correct answer. I think multiple answer is correct. Actually no, always one thing flows. I already, when my chapter videos are coming, then there I will discuss which charge carrier actually carries the current. Only one thing that can flow, that is free electrons. Nothing else can flow. Even holes, they have a mobility, but they cannot move on their own. When an electron jumps from one place to another, then only a hole actually virtually move. Okay, the hole attracts the electron. Electrons move and take the place of the hole, then only virtually the hole can be moved forward, right? But only thing that actually moving is electrons. So electron is only moving. Now a full wave rectifier of diodes D1 and D2 used to rectify 50 Hertz alternating voltage. The diode D1 conduct times on the second. So in a single wave, this is called one cycle, one up, one down. This is called one cycle. 50 Hertz frequency means this cycle is repeated 50 times in 1 second, right? So this cycle, this one cycle is repeated 50 times in 1 second. That is the 50 Hertz. That is the meaning of the frequency of the source. Now, suppose diode D1 is forward bias in this case, then diode D1 will be reverse bias in this case. So diode D1 will not conduct any electricity in this phase, okay? Whereas diode D2 will be reverse bias in this case, and diode D2 will conduct in this case, in this cycle, right? Half cycle. So how many times it is conducting current? So for one cycle, diode D1 is forward bias once. For one cycle, diode D1 is forward biased once, okay, and once it is reverse biased. Now in 1 second, how many cycle is happening? In 1 second, 50 cycle is happening, right? So for each cycle, diode D1 is forward biased only once. So for 50 Hertz frequency, the diode D1 will be forward biased 50 times, okay? The diode D1 will conduct current. Forward conduct means forward bias, right? In reverse bias it does not conduct. Only in forward bias it conducts. So that's why we can take these conducts as forward biased. So forward biased will happen only once in each cycle. That means 50 times in 50 cycles. Now, this is also no longer part of your syllabus. If you want, I can give you, I can discuss this, but correct answer is this. Let's move on to the next question. The energy gap of an LED is 2.4 eV. When the LED is switched on, the momentum of the emitted photon is. This part partly out of syllabus, partly in syllabus. So let me discuss this part, this question. So we know that energy gap is basically related to P into C. Okay, momentum times speed of light. This comes from the de Broglie chapter. Okay, in the dual nature of wavelength and light, you can prove that the energy is basically P into C. Energy gap is basically, here energy gap is given. So basically the energy of the emitted photon is basically 2.4 electron volt. So they might say an electron is emitted with the energy 2.4 electron volt. What is the momentum of that? So for that you can use this formula. Now it is given 2.4 eV. 2.4 eV means 2.4 times 1.6 times 10 to the power of minus 19 joules, right? Momentum we are trying to find, P we are trying to find, C we know 3 times 10 to the power of 8, right? So P is basically given by 2.4 times 1.6, right, times 10 to the power of minus 19 divided by 3 times 10 to the power of 8. Okay. So let me do the approximation again. So 3 was here, 1.6. I will consider this as 1. Sorry, you can use this as well. No point here. No need to apply here. 0.8 is 24, right? 0.8 is 24. So it will be 1.6 into 0.8, that is equals to almost equals to 1.2. Okay, 1.2, 1.3 times 10 to the power of minus 27. So which one is the correct answer? The closest answer is 1.228 10 to the power minus 27. So 10 to the power is matching only in this case, okay, and the value is matching in this case, but 10 to the power is far less. So 10 to the power 21.28, you can calculate it. It will be coming out to be 1.2 point something. Okay. Now next problem. Following equation representing a beta decay, the number of neutrons in the nucleus is, this is also no longer part of your syllabus. This will be 80. This will be 84 after beta decay. Okay, after beta decay, neutron number, proton number increases, but mass number remains unchanged, and then you have to just find the difference, which will come out to be 1.26. A body moving along a straight line with initial velocity v0 is v0. Its acceleration a is constant after 1 second. After 1 second, its velocity is velocity becomes v. The average velocity of the body over the given time interval, there should be a given time interval t, okay, is, so we know that v square is equal to u square, here v0 square, plus 2as, right. So s is basically v square minus v0 square by 2a. Now why we are doing it? Because we know that the average velocity is total distance traveled divided by time, okay, divided by time. That means total distance traveled is this, time is t, any time t, let us assume any time t, during that interval, that is that 1 second interval, okay, during that 1 second interval, any time, any point of time. So this is the average velocity. So which one is the correct answer? Correct answer is this one, okay, v square minus v0 square divided by 280. A particle is in uniform circular motion related to one complete revolution of the particle, which among the statement is incorrect. This is a time saving question where you can answer this question easily without wasting too much time. Displacement of the particle is 0, okay, obviously 0. Average velocity of the particle is 0. Any vector quantity in a complete cycle is 0, so average velocity is 0. Average speed of the particle is 0. Average speed does not become 0 because total distance traveled is not 0. So this is not incorrect. This is actually, this is not correct. This is actually incorrect. Okay, average speed is not 0. Okay, average acceleration, another vector quantity, it is also 0. So velocity and acceleration are 0. Displacement is 0, but speed and total distance traveled are not 0. Okay. Next question: a body of mass 10 kilograms kept on a horizontal surface, the coefficient of kinetic friction between the body and the surface is 0.5. A horizontal force of 60 Newton is applied on the body. The resulting acceleration of the body is about. So this is a very, very simple and another time saving question. So it is mentioned that a body is kept on a horizontal surface. Let me draw it here. Okay, and what is said? The mass of the body is 10 kilogram. Then what is the normal force? Normal force, now let us consider the G is 10. Then the normal force will be 100 Newton. Okay, the coefficient of friction is given 0.5. Then the frictional force is mu n, that is 50 Newton. Okay, so that means, and we are applying a force of 60 Newton. So what is the resultant force? Resultant force is given by 60 minus 50 is equal to 10 Newton, right? Simple. Don't waste too much time, just simply solve it. So 10 Newton is the applied force. Now this is equals to ma. Ma is equal to 10. Now mass is 10 kilograms. So acceleration is a 10. So a is 1 meter per second square. Okay, this is a very simple question. Don't waste too much time on this. Just solve step by step. Do the solution in the diagram itself and then just put the value. Okay, do not waste more than 1 minute in this question. This can be easily solved. A ball of mass 0.2 kilogram is thrown vertically down from a height of 10 meters. it collides with the floor and loses 50% of its energy and then rises back to the same height. The value of initial velocity is. This is little longer, this is little lengthy question, but I hope mathematically it is not very difficult. You can solve it. So it is said the object is being dropped from a height of 10 meters. Okay, so it is dropped from a height of 10 meters. So height is equal to 10 meters with some initial velocity, say v. Okay, when it is touches the ground, it loses 50% of the energy that is it has. Okay, so kinetic energy, conservation of energy is not happening because energy is getting wasted, and then it is rising to the same height. It is rising to the same height. So first let us calculate what was the energy when it started first time. So what was the energy? There are two types of energy. Total energy at the beginning E naught was mgh, obviously mgh, that is the height, plus it has some kinetic energy, that is half mv square. Now when it reaches the ground, 50% of it is lost. So after collision, once it started going back again, at that point its energy E is basically half of E naught. Why? 50% loss means half of the energy is lost, right? 50% loss means half of the energy is lost. So it should be equals to half of mgh plus half mv square. Now this energy takes it to the same height. This much energy takes it to the same height. That means it gains this much energy, right? This value should be equals to the mgh, because at this point again the energy will be mgh only. Now it has no extra velocity, it has only this mg potential energy. Now you have to solve this equation. So m is common, m will be cancelled. Now take this 2 here, so 2gh is equals to gh plus half v square. Now cancel this, take this gh on this side, so half v square is equal to 2gh minus gh, that is gh. So v square is equals to 2gh, okay, or v equals to square root of 2gh. Now what is g? G is 10, h is also given 10 meters, so 10 will be come out, 10 root 2. Now if you see the answer, there is no 10 root 2 is given, so we have to put the value of root 2, which is approximately equals to 1.4, that is 14 meter per second. Okay, this is the correct answer. If you have any doubt, don't forget to mention that in the comment below, and try to solve these questions as quickly as possible. Do not waste too much time, even though mathematics is little bit longer, but the process is very straightforward. The moment of inertia of a rigid body about an axis. The moment of inertia of a rigid body about an axis does not depend on its shape. No, it depends on its shape. Okay, does not depend on its size. No, it depends on the size. If you have seen different objects, for example a circular ring, circular plate, a square plate, they all have different moment of inertia depending upon the length, depending upon the shape, depending upon the size. So these all are not correct. Depends on the position of the axis of rotation. Yes, it depends on the axis of position of the rotation. Does not depend on its mass. It depends on its mass. mr square, by basic definition for a single point it is mr square, right? So it depends on the mass, it depends on the axis of rotation, it depends on the size, it depends on the shape. Okay, so everything is depends, only one of them is mentioned actually depends, otherwise they have mentioned not depend. So those three are wrong, only this option is correct. Now 7 identical discs are arranged in a planar pattern as so as to that they touch each other as shown in the figure. Each disc has a mass m, radius r. What is the moment of inertia of system of discs about the axis passing through the center of the central disc and normal to the plane of the all discs? So this is the combination, and they have asked you to find the moment of inertia about this center. Okay, they have asked you to find the moment of inertia about this center. Now if this is r, okay, then from here to here will also be r, So this total distance will be 2r. So distance between the center of any two disks is basically 2r, right? This is also 2r. This will be very handy. Now, what is the moment of inertia of a single disk? If there is only one disk is here, what is the moment of inertia of that disk? Moment of inertia of that disk will be, so let me write the moment of inertia of only one first, m r square by 2, right? M r square by 2 is the moment of inertia for only one disk. Now, moment of inertia of all other disks will have two components. One component will be along this axis, another component will be this parallel axis, right? Now, parallel axis theorem is now deleted from the KCET syllabus, but it is there in JEE, so I am solving it. Now, for all the 6 circles, it will be same. All the 6 circles, it will be same. What will be that? 6 times. Obviously, each of them will have this mr square by 2 component, that is they are passing through their center. Now, along with that, they will have a moment of inertia along this axis. So, that will be mr square, that is m 2r whole square. Okay. So, it will be you can calculate that, it will come out to be 55 by 2 mr square. This is not included in your syllabus, you can calculate that. This part is the main thing that we have solved it. You can check that and let me know if you have any doubt. Okay. Now, the true length of a wire is 3.678 centimeter. When the length of this wire is measured using an instrument A, the length of the wire is 3.5 centimeter. When the length of the wire measured using instrument B, it found to be have length 3.38 centimeter. So, there are given options are measurement with A is more accurate, while measurement with B is more precise. Measurement with A is more precise, while measurement with B is more accurate. Measurement with B is more accurate and precise. Measurement with A is more accurate and precise. Now, accuracy and precision. The question is related to accuracy and precision. Now, which one is accurate? Whichever value is closest to the actual value, which one value is the closest to the actual value, that is called accurate. Accuracy means how close we are to the real value. So, in this case, this value 3.5 centimeter is closest to this 3.678, but so that means this value is accurate. This value is accurate, but this does not have any other point after that. So, after 3.5 there is no more precision. So, precision is how many decimal it can measure. So, here it can measure up to 2 decimals. That means it is more precise, but it is not very much accurate, because it is not giving me the actual value, but it is giving me more precision. So, measurement with A is more accurate, whereas measurement with B is more precise. A stretched wire of material whose Young's modulus Y is given has a Poisson's ratio of 0.25. Its lateral strain is epsilon L is equal to 10 to the power minus 3. The elastic energy density of the wire is, now elastic energy density is given by a formula half Young's modulus times epsilon L divided by Poisson's ratio. This formula you have to remember to answer this question. This is little bit difficult question, because this formula is not very commonly used and not very conceptual as well, but sometimes from time to time this question may come, but if you remember this, you can answer this. So, epsilon L is 10 to the power of minus 3 and Poisson ratio is 0.25. Okay. So, this will cancel, this 0.25 will come up and it will become 4, and this will become 10 to the power of 8. Okay. So, 4 times 10 to the power of 8. To solve this problem, we have to use the formula is that energy density is given by half times Young's modulus times epsilon L divided by Poisson's ratio whole square. Okay, this is not a very common formula, but what to do? If problem comes like this, you have to remember this formula to answer. Okay, now lateral strain is 10 to the power of minus 3 and Poisson ratio is 0.25 whole square. Now this will cancel, will become 10 to the power of 11 times this 0.25 will go up and it will become 4, right, and this is 10 to the power of minus 3. I hope you know that 1 by 0.25 means 4. Okay, 1 by 4 is 0.25. Similarly, 1 by 0.25 is 4. So it will become 10 to the power of 11 times square of 4 is 16 times square of 10 to the power minus 3 is 10 to the power of minus 6. So the answer will be 16 times 10 to the power of minus 5 SI units. Okay, so 16 times 10 to the power 5 joule per meter cube. Okay, now 57. A closed water tank has cross sectional area A. It has small hole at the depth of h from the free surface of water. The radius of the hole is so that r is less than a by pi if p naught is the pressure inside the tank above the water level and pa is the atmospheric pressure, the rate of flow of water coming out of the hole, rho is the density of water. This is also not a very common problem, but you need to know the speed of a flux. Speed of a flux is given by 2gh plus 2 p naught minus pa, p naught minus pa by rho. Okay, now the flow, water flow, the flow of water is given by A times V. Okay, this is the continuity equation. Flow of water means area times V. So what is area? Area of this case is, this is the area R, right? This is the R. So area is pi r square. So pi r square times this. That means correct option is option A. 100 gram of ice at 0 degree Celsius is mixed with 100 gram. 100 gram of ice is mixed with at 0 degree Celsius is mixed with 100 grams of water at 100 degree Celsius. The final temperature of the mixture is, take LF equals to 3.6 10 to the minus joule per kg, etc. So this is also a easy problem but little lengthy problem. So first what will happen, let us understand the process first. The process will happen like this. First ice will melt. So the ice will melt to water to form water. Okay, then it will mix with the remaining water. Okay, and finally they will attain a final temperature. So this is the step. First this ice is mixing with the water, then it will melt and both the mixture will be attain a final temperature of single temperature. Okay, so the first stage is how much energy is required, how much heat energy required to melting this ice. To melt this ice, the energy required say 1 is mLF, right? This is the energy required to melt that ice. Now this ice will finally start with 0 degree Celsius and it will reach a temperature of T degree Celsius, say. Okay, then what is the energy required to transfer this 0 degree Celsius water till T degree Celsius water is m s delta T, right? That is T. 0 minus T is delta T, T minus 0 is delta T, right? So this is T. Now in same case, the water at 100 degree Celsius, it will start at 100 degree Celsius. Okay, it will mix with this ice and it will eventually attain a lower temperature of T degree Celsius. For this it will be m s 100 minus T. Okay. Its final temperature is T, initial temperature was T, so delta T will be 100 minus T. Now, why I have written m for everything? Because if you see, this was 100 gram, this is also 100 gram. So, I have written both cases 100 gram. If this was 100 gram, this was 200 gram, then this would have been different, right? Now, since they have all 100 gram, I don't need to convert units and do a longer calculation. I can simply cancel them. Now, LF is given as 3.36 times 10 to the power of 5, okay, plus S is given as 4.2 times 10 to the power of 3, okay, equals to S again 4.2 times 10 to the power of 300 minus T. Okay. Now, let me simplify this a little bit. If you see, there will be a T here. Okay. If you see, what we can do is, this will be cancelled, right? 1, this will become 2, this will cancel. So, 2 means 336 plus 4.2 T equals to 4.2 times 100, that 4200 minus 4.2 T. Okay. So, what will happen? You take this on this side. So, 4200, this only 4200, this will be 420. Okay. 4.2 times 100 means 420. Sorry, my mistake. So, it will be 8.40 will be 420 minus 336, that will be 84. So, it will be 8.40. So, let me write it here. So, T will be 84 divided by 8.4, that is 10 degree Celsius. So, correct answer is option A. If you have any doubt, mention in the comment below. Okay. Now, let us move on to the next question. The PV diagram of Carnot's engine is shown in the graph below. The engine uses 1 mole of an ideal gas as working substance. From the graph, the area enclosed by the PV diagram is. So, this is a very, very tricky question. This you have to find the area enclosed by the PV diagram, right? The area on the PV diagram in the graph. That means you have to find this area. You have to find this area. Okay, not the entire area. You have to only find this area. Now, why this is very tricky question? Because this is not easy to answer without knowing some knowledge, because in this case, this is no regular shape. So, how you can answer this question? The trick is to use the concept that is given here, Carnot's engine. Okay, Carnot engine hint is given. So, we know the efficiency of Carnot engine. So, we will use that and we will find how can we calculate the efficiency of Carnot engine. Now, for Carnot engine, we know that for this is the starting point, this is say temperature T1, TA, and this is the last point Tc. I hope you can see that TA is the temperature here. Okay, and since this is isothermal process, at this point we can write PAVA equals to RTA. Okay, so we can use this. PA is 1600, VA is 2.5 centimeter cube, and this is kilopascal. Okay, so kilopascal is there. Kilopascal means, let me simplify it. Okay, 1600 times 10 to the power of 3 kilopascals, and V is 2.5 centimeter cube. That means 2.5 10 to the power of minus 6, right? Centimeter cube to meter cube is minus 6, is equals to R times TA. We do not know the value of TA. R, I am keeping it as R for now. Now, if you simplify this, you will get 2.5 times 1600. 2.5 means 1 by 25 by 10, 25 by 10. So, we can multiply 1600 times 25, okay, times 10 to the power of minus 7. I took that 25 out, so minus 7 plus 4 10 to the power of minus 4 equals to RTA. Okay. Now, if you multiply this 25 into 16, 25 into 16 means 400. So, 400 00 10 to the power of minus 4 is equal to RTA. So, TA is basically 4 by R. Okay. TA is 4 by R. This 4 zeros will cancel with 10 to the minus 4 and it will be 4 by R. Now, let me find the TC. Same concept we will apply. PC VC equals to RTC. So, we will apply the same concept to find the temperature TC. So, TC is basically equals to 400 times 10 to the power of 3 times 6.25 times 10 to the power of minus 6 divided by R. Okay, divided by R. Let me only keep the values which I need, right, is 4 by R and TC is 4 into 6.25 is 2.5, right. 4 6 are 24, 24 and 0.25 means 25, right. So, 25, but I am writing it at 2.5 so that we can cancel all the 10 to the power values. So, they will cancel 1, 2, 3, 4, 5 and 1 from here. So, 6 minus 6 by R. You can use basic mathematics, it is very easy to calculate 2.5 by R, that is the value of TC. Now, so TA is 4 by R, TC is 2.5 by R. Okay. Now, what is the efficiency of Carnot engine? Efficiency of Carnot engine is 1 minus final temperature by initial temperature, that is 1 minus 2.5 divided by 4. This is the efficiency, okay, or equals to 8, okay, 4 minus, sorry, not 8, 4 by 2 minus 5, that is 1.5 by 4 or 3 by 8. Okay. This is the efficiency of the Carnot engine. Now, the input energy is given as 800 joules. So, it is said that the heat supplied to the gas is 800 joule, that is the energy input. Now, how much work it will do, that is the area under the graph. So, area under the graph represents how much work is being done in that cycle. So, that work done, work output is basically whatever energy you have given, times the efficiency of the Carnot cycle, the efficiency of the Carnot engine, right. Rest of the energy will be wasted. So, energy given is 8000 joules and efficiency is 3 by 8. So, it will turns out to be 3000 joules. Okay, 3000 joules. Do not go and try to calculate this area. It is very difficult. None of them are straight line, they are curved lines. So, if you think I can calculate it using the line, calculate using the area, not possible. Okay. So, in this case you have to use this logic. This is a little tricky question, it is complicated question. In fact, in the entire question paper, this is the most hard question that I have seen. There are few hard questions, but that are now considered to be a deleted syllabus. So, I am not considering that, but from the in syllabus, this is one of the very difficult question. When a planet revolves around the sun, in general, for the planet, the linear momentum and aerial velocity are constant. Okay, it is rotating. Remember, it is rotating or revolving. Okay, so in revolving motion or rotational motion, linear momentum need not to be constant. Okay, it can change, but angular momentum has to be constant. Okay, so angular momentum about the sun and the aerial velocity of the planet are constant. Aerial velocity is always constant, that comes from the Kepler's law. So basically this is the correct answer. You can check the other options as well. Kinetic and potential energy of the planet are constant. It is not constant. Kinetic energy and potential energy are interchanging. We know that at some point the kinetic energy is maximum, some point potential energy is the maximum. Linear momentum and the linear velocity are constant. Linear velocity is obviously not constant. It is changing at each and every point, right? So only correct option is option B. Now so far we have already completed question paper of 2024. Also we have completed 2023 paper. And if you find our channel helpful, don't forget to subscribe to our channel and share it with your friends. Thank you for watching.